I'll run the eagle eye down distal to the area of concern. I'll start recording with my sync turned on. I find a spot where the distal lumen has less than 50% plaque burden. I'll start my calculation there. And with co-registration, I'll calculate the length of the stent at that point. Look for calcium, which is going to inform my decision as to whether or not I need to go in with something like an angiosculpt or atherectomy devices in order to modify the lesion to ensure that my stent is well expanded. And from a practical standpoint, usually if it's not 270 degrees or more, I'll go in with a high pressure balloon and make sure that it expands. And so I'll press forward. If not, then we have to talk about atherectomy options at that point. And then I'll find a spot proximally when possible that has less than 50% plaque burden so that I know that's where my proximal stent edge is. And with sync vision, I can scroll through, find that spot on the angiogram and not have to guess as to what my landmarks would be in order to achieve those outcomes. So deploy the stent, post-dilate with a high pressure balloon. In the ultimate trial, everyone got a balloon dilated to 18 atmospheres. Once I've achieved that, I'll put the IVUS back down. So again, put the eagle eye distal to the stent and make sure that I was right. My distal stent landed in a good spot. It's less than 50% plaque burden distally and proximally. I'll find the smallest part of the stent and calculate the minimal stent area, making sure that that is bigger than the distal reference lumen, or at least 90% of it, if not bigger usually, or at least greater than 5 square millimeters. Sometimes, again, with smaller vessels, you can't really achieve that quite as well. And then making sure that there's no edge dissection. So I try to put into practice what I teach colleagues and fellows. I try to, as I said, use this 100% of the time because I truly believe that it matters. And we'll go through some of the data that shows that.